we have something called a gen phrase paraphrase maker that we can enter. We're going to call it say. We're going to stick with format, and the reason why is we want to have one particular predicate that we use to communicate with the player with, except this predicate is going to be overloaded to say something like, and we're going to create a gen phrase off of this. Moo declare gen phrase, how generate phrase, and it will be something like, in regular Prolog, this is called message string. Swipe Prolog input. What we're doing is we are modeling, and we might actually just even use this predicate, message to string. Let's say message hook. Yeah, print message. Okay. Let me see here. Okay, so let me see how we got our print message. Well, they have an anglification here system here. That's what we're actually looking for is, oh, message to string. Okay, so Prolog has a way. I mean, we could reuse this predicate, and I'm tempted to. Let's see how much it's been used already in the system. Listing. I want a listing of, or I want a Prolog listing of message to string. Why is this thing being slow? We don't know yet. Just did that before a moment ago, right? All right. Let's let it update. Okay, now we'll ask. All right. Something was going on. Okay, so what we'll do is message to string 3. And what package is this exported from in Swipe Prolog? I bet it's under messages or debug. Irregardless. It's a built-in. Okay, well anyway, let's try it again. We'll reconnect. And we'll have also can run a local copy of the MUD. Oh, by the way, we finished our command, right? Maybe we wanted it in better English, so maybe we're not quite done. It is in less than a half hour, I would believe. Singleton variable agent. I think I keep thinking I'll fix it, and I don't. Let's fix that right there. Okay, this is the MUD. Again, it says in our line 41 where, oh yeah, it's missing something. So we're going to use message to string where message. Okay, first of all, I want to get a listing of message to string to see how people already use it. Prolog. Okay. All right, translate message. Actions to format, and then print it in a format. Okay, so actions to format is defined where I kind of like using the Swipe Prolog predicate instead of inventing my own. I'm sure Andy likes that too. Actions to format. So what's up here? Why am I not finding it? Okay, it's not defined, huh? Let's see. I want to figure out message to string, and I want to know it. See if this is legal. X. No, it didn't find X. Okay. Predicate property. I'll find out what module is supposed to export that. None of them, huh? Okay, what about message to string? It's interpreted, built in. Okay, imported from messages. Okay, so what I'd like to do is a listing on messages and action 2 format. Okay, there we go. This is how they define actions to format. Concat. Okay. We don't have to do it this way, but okay, and that's part of messages. So what's the best way in Swipe Prolog to hook to install ourselves in here? I bet it's message hook. Okay, well anyway, using this particular format is what we are doing with our own database here. So we're going to say, we're going to call it Anglify. We're going to say term. We're going to call it term Anglify. It means convert it to English. So we're going to say term English. And I'm going to call it declare term Anglify. And it's going to be kind of like a hook predicate. At location, I might even be able to do it without a body. Let's just do it as a fact. First, we're going to say this is how we interpret at location. And we interpret it this way. We say obj is at location. And when we we're going to change, we want this to be a noun phrase. As object as noun phrase. And then we are going to say location as noun phrases too. Right. And is at. Okay. So whenever we want to translate this term to English, we use this prescription to get it there. Now we also have to describe what I just made up the word as. Part of this is, this is probably going to be broken into way more than just one whatnot, because what you're seeing is a design process the Prolog programmer uses. Okay, as a type, as a noun phrase. Okay, I'm going to leave noun phrase there. And I want this predicate never to fail. So I'm going to say the. Not even the. Let's say the, we'll use the object named. The object, we could say the object with token obj is at a location is object at. Okay, so I'm going to use this as, I'm going to add a cut to this because I have one here that's creates a string. Okay, and the string is going to be name strings. Here's why I'm using name strings. Because name strings tend to dictate things. So if Picard was in the turbo lift, the way we would say this, we would say turbo lift. So, kind of in a way. Okay, so name strings, object, some string. There we go. Okay, so that's how that's done. However, since rooms tend to have an XYZ coordinate with them too, we're going to say that if the object is a region, and how do we do that? We look at our world in 2 dimensions, and we convert worlds to region. Okay, find region. location to region. Okay, so we get from XYZs into region names, we use the location to region predicate. So I am going to take the OBG variable really didn't matter. That it's the same as location variable. So I'm going to call this region. And I am going to make this predicate start over like this. So if I find a location to region, I want to simplify that to simply the region, and now I'm going to anglify the region as a noun phrase, and I'll end up dropping the XYZ coordinates because that might not be appropriate in English. So that's important. Okay, so what I want to do is if the name strings are found, I don't want it to go on to using this particular default is said with the token. I also might want to capture type, say something as a type, the object with type with token. Okay, that's how I say it. All right, so just these 4 assertions are going to allow me to speak English easier. Oh, I put the word where. I might say command result where. So arbitrary, I know. But I just want to show you an example of how simple Prolog is to use. Command result of command is whatnot. And I will say, I'm going to anglify that as the command result of CMD is whatnot. Okay. And so what happens is instead of printing the word whatnot, it's a variable, and so it's going to actually get resubmitted back into the anglifier. So hopefully it'll end up saying in the end. Actually, before I even do the end, let's do this. We're going to create a small local. This is, let's say, moo, declare a term anglify, x, y, and this is a wrapper interface to this x, y. The reason why is because I have my reasons. I didn't even have to do it that way. No, sorry, I wasted time with that. Let's just do it correctly here. Okay, so this isn't quite correct, but I'm going to say there's a format E command, and what its mission is to take a term and convert it to English. And so it does so by checking to see if there's an anglification of the term. English mid. This video is probably going to end up being called something like an hour in the life of Douglas, but not necessarily tutorial video. But okay, and then what we want to do is we want to take that English mid. We're going to have a predicate called fully expand English mid to English. Otherwise, okay, so fully expand though, I may as well call it English for a term, because term is going to have to take terms. Okay, so we'll do it like this. English. Okay, probably wondering why. Looks like I'm just cut and pasting the same thing. It's because sometimes the way we write Prolog looks a little bit like this. yeah, I call it English, and then I'm going to fully expand. The way we use fully expand is, yeah, fully expand T to E. And then I'm going to fully expand, turn to English. And I'm going to say that there is a fully expand default, and that is going to look like T to T. And, okay, so if we're coming into fully expand with a variable, we want to just sort of accept it as is. And actually, anytime it's not a compound, even a variable, we're going to go ahead and accept it as is. Okay. Now, fully expand is going to have to recognize situations of terms that can be anglified. I want that to almost be a default. I want to see if there's not a compound there, and I might feel like expanding it. T to E. I believe that this predicate could get called by something using find all or something combinatoric. I kind of overguard my predicates. But green, is there anything called green cuts? This is a red cut. That's a green cut. I think, I hope. Okay, so this is almost how I want fully expand to work. But, you know, I want this part to be done differently. I'm going to call it out. I'm going to put append into English, out. Actually, I want to flatten append, meaning I think I have a predicate called flatten append. I don't know what's coming in here is going to be a list or not. So I'm going to listify these two things and then flatten them. And then what's going to come out is that. So here's how flatten append works. We put flatten, it takes first, last, and always. We flatten first to first flat, and we do last to last, and now we get to use append. Okay, here it is. Also, since I want to be able to submit atoms into this, I'm going to do this. Being my favorite green cuts because I don't want this thing backtracking. Okay, so now that I added the braces around there, I can take these off. Okay, so I'm going to be appending E with English, and that's going to create out. Fully expand, I believe, if it comes across this, its goal is to when I'm calling fully expand is that it will only return when fully expanded. So therefore, I can believe that these two guys are going to fully expand something, I think. So let's see here. We've got our format E, and then from this part comes our English. Okay, so we are going to format print English back to the user. And that should be what happens here. Okay, so we're up to almost an hour. Let's see if we fully expand is got singleton variables. I believe it. Okay, so let's see what we did wrong. TE. Didn't quite. They're just not grouped together. Okay. Why are they not? I see. We got this one down here. See what happens. Okay, no warnings. That's probably correct. Okay, so now we're going to ask where is Picard. Let's see if where is Picard? The command result of where is at location Picard is here. Okay, so we need whenever we come back with a term anglify, we need to fully expand the term anglify. That's what we're missing here. So we're going to say TA for term anglify, fully expand TA to E to English. Now let's try that. Reload it in the game. Where is Picard? Alright, so here it is. We had an error. We had a resource stack error. Okay. It'll restart, and it's restarting automatically. We can't kill this thing. It's running in a VM. Okay, fully expand. I want to put a green cut there. You're probably, if you're a Prolog programmer, you probably see my programming error right now. I don't yet, but I will figure it out here in a second. Okay, E to English. These things get appended. Gotta have my overly green cut. Okay, term anglify. That's right, I wanted it to take a default, but I didn't, so. Declare term anglify. Sometimes I don't think I don't need cuts even though. Okay, so let's see that on the reloaded term, the reloaded system, which is, I take this and move out of the way so I don't keep alt tabbing. Okay, there we go. All right, so let's see if we're back in the mud. I'll hit refresh, and so that'll make us reconnect. Okay, so where is Picard? Alright. Crashed it again, stack, call command, explore, where is Picard? Okay. So let's, here we got first, last, is that spelled? Yeah. Correct. These are all terms, these are all lists. Okay, so let's see here. I'm gonna look, right, make, and we'll reload. Fully expand. Actually, yeah, I'm gonna put this here. It's possible a variable slipping in somehow. Okay. And the other thing is I can go D and type debug. This is why sometimes you want to have a local server for debug. And now I'm going to say where is Picard. And now hopefully it'll let me fix the error. Yep. Okay, so the error was resource stack. Now I'm going to say leap. And hopefully if I'm tracing correctly, nope, I'm not. I'll be able to trace it down. So let's do that. So I'm going to be looking for here is when that number on the left-hand side starts to grow faster than it should. That's what we're looking for. Right, say it gets up to 90, then we know that we're lost in space. There it goes. You know, I think I can get away with going up. Okay. There's our atomic list concat. That's okay. I think we're still in our parsing code, so I'm going to say up, up, up. Okay, there we are. What is the exception? This is, we actually already created we're already in the exception code. We are looking for. Yeah, it's okay. I'm going to type tilt leap, TikTok. Okay, where is Picard? Looks like we have a few enter keys in the queue.